All right, if you are doing analytical geometry and calculus, let's do this video together. So we have been given an equation, a polar equation actually, and the first question that you are asked to find is to identify the type of conic. The type of conic it is. So to know the type of conic it is, we first have to rewrite this one into a standard form. One thing that you need to understand is that the standard equation of a conic whose focus is actually at the pole, like at 0, 0, with eccentricity E is given by R is equal to ED over 1 plus E cos theta. Now, one thing that you need to understand is that in this case, E is just our eccentricity. Okay? And well, because of that, here's what we're going to do. We'll do something simple. We just have to compare this to the equation that we have there. So, let's compare. Let's compare. 6 is equal to ED. That's what it means. Okay? But look at what is here. The 2 is here is equal to the E there. So our E is 2. Our eccentricity is 2. Now look at E is bigger than 1. Right? So since E is bigger than 1, these are just things that you need to know. Alright? The conic is hyperbola. Yeah. So when the eccentricity is greater than 1, you get a hyperbola. Now, let's talk about the next part. Let's find the eccentricity. Eccentricity, we already found it. E is 2. See, we want to convert this into Cartesian coordinate. I want us to convert this into Cartesian coordinate. So to do that, we have, remember that we've been given this 1 plus 2 E is also cos theta. Or what you do, cross multiply. All right, so this will give you R 1 plus 2 cos theta equal to 6. Now the thing that you need to understand is that expand throughout. So this will be R plus 2R cos theta is equal to 6. Now we are going to use the relationship for the triangular coordinate. You know this, right? For radius, isn't it? You know this relationship. Now, at the same time, we need to understand to say x is R cos theta and y is equal to R sin theta. This is the only way we can convert this into Cartesian. So, have you seen where there's R here? I'll substitute x squared plus y squared. Then plus there's 2. Have you seen R cos theta? R cos theta is here, it's just x. 6. Then I think from there, everything is done. Let's just push everything else together, the other side. So 6 minus 2x. All right, if I multiply both sides, square, I'll get x squared plus y squared is equal to x. So it's 6 minus 2x, I'll do square. Of course, we can expand the other side. So you get this. This will be 36. 6 times 2, negative 12. Double it, you get negative 24x. Squared, negative 2x, you get positive 4x squared. All right, then just rearrange everything. So we have, so I can say 4x squared minus x squared minus 24x minus y squared plus 36. That is equal to 0. So I'll end up having 3x squared, of course, here. Then minus y squared minus 24x plus 36 equal to 0. Now, someone might say, can I just end here? Well, it's up to you. You can literally end here. But we can do something better. Let's first factorize this x there and the x there. Meaning if I took out 3x, I would remain with x. Let me just take the 3. Yeah. along with x squared minus, if I took a 3 here, 8x. Then this will remain y squared plus 36 equal to 0. Just like that. I think now we are moving somewhere. Yeah, we are moving somewhere. Now, just complete the square. You can complete the square here. If I complete the square here, I find half of this, right? Finding half of this, so this will be this. I add and subtract it at the same time. So half of -8 is -4. Square it and add it to the other side. So if I square -4, that would be 16, right? Meaning I have to subtract it at the same time. That's what it means. So the 16 will be here, but to be like this. Yeah. Then y squared plus 36 equal to 0. Expand throughout, so you get 3. X minus 4 squared minus 3 times 16, what do you get? So that would be 18, remainder 1, 48. Yeah, minus y squared plus 36 equal to 0. Then to subtract, I should be able to get -12. So this would be 3x minus 4 squared. Subtract there, you're getting -12 equal to 0. Yeah, if you want, you can now, you can see that you are getting something here. Like the hyperbola is coming out. You can see it, right? The hyperbola, right? Now, where we've reached here, ladies and gentlemen, just take the 12 the other side. Okay, minus y squared is equal to 12. Then divide by 12 throughout, divide by 12, divide by 12. And we end up getting 3 into 12, that would be x minus 4 squared over 4 minus y squared over 12 equal to 1. This is the final form. This is that's why we said this one is a hyperbola. You see that it's the same shape, it's the same equation of the hyperbola. Right? Thank you for today. I'll end here.